So I think we can start. Several people have arrived, so we'll start. Hi, I'm Daniel Siegl. I'm from LieberLieber Software, and today I'm gonna introduce you into Agile modeling for safety critical environments. As you might hear, I'm not Native American nor Canadian. LieberLieber is an Austrian company with a branch in the US and some activity in Canada, and our main market is Germany. We grew up in the German automotive industry and are supporting various players there with our solutions and our know-how on modeling for safety critical environments. I started my career more or less as an enterprise mobility guy, but I was always interested in developing tools to make development easier, more sustainable, and so on. So I ended up building engineering tools and solutions around for modeling tools. Currently, I'm heavily involved in model-based systems engineering around the globe in standards organizations. I am also deputy director for standards in COSI or in the ProStep, which is a German automotive association. So I try to stick around and see where the trends are going. The typical companies we work for are people that build safety relevant cyber physical systems, like automotive companies, aerospace companies, but also garage door openers or people that build satellites. So it's a wide variety, but typically the focus is always on fulfilling safety critical norms in an agile manner. When we look at our references, this is just the automotive page. You can see we work heavily for Volkswagen. We have work at Daimler, Continental, Schaeffler, Bosch, or Veoneer. So many organizations that work with autonomous driving in these bigger companies work with our solutions because obviously they need agility and MBSE to be able to deliver self-driving cars. In Japan, for example, we work with Daihatsu and Subaru, or in Korea with Samsung. So we are a small shop to some extent, but we have a global customer base in very dedicated markets. We are also in the defense side of things, on one side in Europe with the Bundeswehr and the Swiss Army, on the other side also in the US, working for defense companies like Raytheon, General Electric Aviation, or Thales. So let's start with the agile things of the world, yeah, and why it's a challenge to build safety critical systems in an agile way. Agile is widely accepted in the line of business software development or product development area. And nowadays, with the challenges ahead and the increased complexity of the cyber physical systems we need to deliver, we also need to take some of those agile approaches on board for the safety critical. And in an agile project, you do not absolutely know for sure what you're gonna build. You start your project with maybe a bit wider scope, and you learn to narrow down your scope to deliver a solution that will satisfy the requirements, that will satisfy the norms, that will satisfy your customers. And so it's not like the old traditional V model way where you try to specify everything before you start engineering. You try to adapt, to be faster, to do sprints, to learn quickly from mistakes you made, what you need to alter. And so every of these points, of these intermediate results, and an intermediate result is not necessarily a shippable product. It can be a set of test cases. It can be requirements. You always think about what have you done and how can I go back? Because it also happens that sometimes you need to go back a full sprint. You find out this was not a good choice. So you need options to change your decisions, move back. start over, do refactoring, and this is really what it is all about. So when it comes to safety critical projects, you obviously have a lot of different requirements than a classical line of business project, or if we develop a game, you have to make sure you do everything that is state of the art, not to endanger people or things. So you need stuff like safety analysis, you need continuous traceability, you need a very good way to manage change, to handle change requests, and you need to prove on the other side of the V model that you can do your verification based on the requirements. And requirements can be technical requirements, functional requirements, and so on. We quote here Bruce Paul Douglas, who is now an independent consultant. He even wrote a book about Agile, MBSE, model-based systems engineering. And that's the challenges we have to face in today's world with systems engineering and engineering in general when we build Agile systems. And to solve these models of the system, models of what we're gonna build, play a really crucial role. To master all of these challenges, there is several solution strategies. Typically, model-based systems engineering is a very important one. It helps you to build your traceability, map your requirements to your architecture, to your product specification. And because it's agile and moving on, we also need advanced configuration and change management in the software world. This is very common in the modeling world. This is one of our core expertise, how to make agile configuration management that can also handle models, and agile development. And all of this helps you to manage the complexity of the challenges that today's systems provide for us. And also, for example, ASPICE is a automotive norm that describes what your software has to fulfill in order to be relevant for a safety critical application. And you can see that there is a mapping. The only thing is you need to think a little bit different, because most of those documents are written for classical V model. But if you think through it, there is a what level and a how level. And so the mapping is not as far as apart from this traditional norms like ASPICE to a more modern approach, how to tackle the challenges of a project in an agile way. So the only valid question is how will you do the concrete process, okay? And not, I cannot do agile because I have to work in an ASPICE way. If you look at the mappings, this is from Fraunhofer Institute, a very well-known research institution in Germany. There is a real mapping between an ASPICE structure, this way how to manage your software products, and how you do Agile. Be it Scrum, be it XP, doesn't really matter. It's always about how to make a mapping, to make it acceptable for your safety critical projects to work in an agile way. If you look at the compliance between agile methods and ASPICE, you can see that for this automotive ASPICE, which is just an example, there is norms like that for aerospace or space as well, that you can map most of the stuff directly, more or less directly. For some rules, you might need to find ways how you can prove you support it, but you can see that the overlap is pretty big, because generally 87% of the Scrum ideas are used if you map it to ASPICE. And that's really an interesting finding. If you hear people talking about Agile, they say, Agile means no documentation, Agile, blah, blah, blah. In reality, if you look at successful Agile projects, they all have documentation. and they all move in a structured way, but they work in parallel. They work on requirements for one function while they still develop the previous function. Again, back to the solution strategies, we will now look at an ISO norm, the ISO 2622, which is the automotive representation of safety critical software norm. It is derived from more generic norms, so the same principle applies also to other industries. As you can see here, you have to deliver a lot of artifacts to comply to those rules. And it's virtually impossible to deliver these artifacts in a provable, consistent manner if you do not use models to create those artifacts. So one of our customers once said, safety needs models. So this is really a key thing. If you have to deliver safety critical products in a fast way with today's complexity, you really have to look into creating models to describe your system. The value of modeling is on various levels. One of the levels is the models help you to understand the problem. So it's a communication medium. It helps you to discuss with the domain experts what you're gonna build. On the other hand, the model helps you to find a solution. You can map out various scenarios, look at them, decide what fits the most requirements with the least components, what is the most beautiful solution in terms of simplicity. And also the model in the long run will serve as a knowledge database for your projects. The model is your knowledge base. The model is a graph. You can query it from various perspectives. The most common, when people hear modeling, they will think of diagramming. They will think of trees that represent the model. But this is just one possible view. In reality, it's a graph that you can query from various entry points. And the interesting thing about these models is that you map requirements with components, that you map requirements with software architecture, that you map requirements with hardware solutions and so on. And therefore you get a very structured graph that you can use to derive those artifacts that you need to deliver for a safety critical project complying with the ISO norms. So another thing that we hear very often when it comes to modeling, oh, this is such an overhead, we don't have the time. And here's an interesting study from Sascha Kirsten from the Technical University Munich from 2011. So it's already almost 10 years old, but we feel it's still very valid, and it becomes more and more valid the more complex the solutions get. This is for your very first project where you use model-based engineering. On the downstream of the V model, you will see higher efforts, you will see higher cost, you will see higher times. But on the upstream and in the implementation phase, you will already make up for it, and you will end up with a better product at a lower cost if you start to do model-based development or model-based systems engineering in early stages in your projects. So again, back to our agenda thing. Now we look at the configuration management. The goal of the configuration management is typically that you can do a systematic tracking of the changes you did in the past, prevent you from doing unwanted effects. It helps you to preserve the integrity of the system. You can do changes at any time. And it's a standardized process to make changes, to alter your artifacts, to alter your models. And this is really important because Agile also needs some kind of branching capabilities. Otherwise, it will get very, very weird. You have work in parallel, as we said before. On some components, people might still work on the architecture, while in other components, people might already develop software. And or tests and so on. So you need to have the capability to branch out and bring stuff together. When we look at our customer base, you have seen it's automotive, it's aerospace. The best practice really at the moment is to do a feature branch-based approach. The most famous one is called Git flow, and with our tools we can support this for MBSE or for UML to work with your models. And again, all of these version control systems will help you to get your certifications faster, to understand the changes you did in the past, to have the chance to revert to a point in the past and say, okay, let's do it in a different way. And obviously, if you branch and bring stuff back in, you will have some conflicts that you need to resolve. But conflicts are not bad. It's just a name that sounds a little bit negative, but it's not really bad. And so one term that we hear in the software a lot is continuous integration, or DevOps. With our customer base, we really feel this might be the next big thing in 1 or 2 years, that people also want to do CI, continuous integration, or DevOps for models, to run automatic validations on the models, to export artifacts created from the models automatically. A valuable model must be alive. It needs to be sustainable. And you can only keep your engineers maintaining the model if it's important, if you export stuff that matters. If you model just for the sake to model, don't start. You have to make sure day one that you will derive stuff out of the model that delivers real value and helps you to keep it sustainable, which basically means that the model is part of the definition of done, just like you would do with documentation in other cases. And this is created by our boss, Dr. Konrad Wieland, who has a PhD in model versioning, is the Agile Modeling Manifesto. It has been quoted at some conferences already, which made us smile a little bit. Models help to understand each other. Very important part. You use models because the complexity of the systems we got to build is too big to oversee it if you just write Word documents. The model is evaluable and consistent. You can evaluate it with a human, you can evaluate it with scripts, you can run queries against the model. So it's not just diagrams, it's the graph behind it, as I shown before. And we shall not forget that the purpose of models always was to create something machine readable. Also with the models, you have with models, UML or SysML, you have a very good way to discuss with stakeholders if you fulfill their needs, or if you're over fulfilling, maybe delivering too much. And the models also help to manage the complexity, which is one of the key things, because if you look at an autonomous driving algorithm for a car, it's not very funny to document that in a Word document. By the minute you save it, it will be outdated, and a model helps you to break it down in elements, to create connections, to make the data more accessible and more consistent than you would end up with Office tools. And it's natural that the model will evolve, it will change. And that's why you need a very good configuration management. Our approach, our DNA basically says reuse stuff that you already use in the software engineering, like Git, like PTC Lifecycle Manager. Reuse that for your model. Obviously, we are a commercial company, so if you ask me which modeling tool to use, I recommend Enterprise Architect for MBSE. And with our Lemon Tree extension and our know-how, we can really help to make it agile and to to give you a support for Agile model-based systems engineering or Agile in general. So this was, oh, there is an old banner, very funny. This was basically the overview I wanted to give you today. If you have questions, feel free to reach out to sales@lieberlieber.com. Here is some more names that rely on our tools. If you have questions, I'm more than happy to answer them. You can type them in the chat or in the question and answer module, and I will stick around for a little longer.